So read the section on deviations from matching first, and then watch this video, and hopefully it all makes sense. Since you've read the section already, you've already read that the matching law, actually only emerges if there's some cost to switching from one choice of behavior to the other, from one schedule to the other. And so there's this changeover delay. If you can just go back and forth, then the matching doesn't emerge. You don't spend twice as much on the one that reinforces you twice as much. You're just randomly going back and forth. So examples of a changeover delay. What does it cost you if you stop doing one behavior and start doing another? So let's say I'm working on my computer and I get the urge to check my email. Well, if I have to actually find the icon, click it, open it up, type in my password, and now I can see my email, that takes some time. That's my changeover delay. It's the delay in me getting my reinforcement because I had to switch from one behavior to another. I always think of if you stay at a hotel and they have satellite TV, or maybe you have that at home, and you change the channel, it drives me crazy because like you push the button and you see the little numbers change, and then there's like this pause, right? And then the picture comes on. It's like, I sit there always going, oh, the changeover delay is such a pain. And we're like pigeons sometimes. We get really impulsive. We want our reinforcement now. And so when I have one of those TVs and I'm like, and let's say, you know, I'm sitting here watching Pawn Stars, you know, that pawn shop store show, and versus, you know, Storage Wars, where they bid on, you know, these two silly reality shows. And if I'm going to flip back and forth, because I find both of them mildly reinforcing, but one more than the other. And I would normally, you know, match, because there's this changeover delay. I mean, I would have to, sometimes you get to the point where it's like, it's not even worth it changing the channel. I'll just keep watching this one, right? So that's a changeover delay. What does it cost you to switch? In your book, it gives examples like if an animal can get food in one field in the forest over here, the changeover delay would be how long does it take for them to travel from one food patch to the other food patch? All right, so there are 3 deviations from matching. An animal, given the right circumstances, or a person could match. They're gonna, you know, do more of the behavior that gets more reinforcement. Now, sometimes we don't do it perfectly, or animals don't do it perfectly. So there's overmatching, undermatching, and bias. Let's see, your book starts off, we'll follow it, with undermatching. Okay, so to understand these deviations, think of it this way. If I have 2 choices of behavior, and I spend equal amounts of time on each schedule, each behavior, that will tell me 2 things. Either I find both of these things equally reinforcing, which could be, or at the very least, these aren't 2 different things, but at the very least, either I find them equally reinforcing, but what if, let's say one of them actually does pay out more. Let's say this schedule over here, I'm a pigeon in a box, and I have 2 keys I can pick. And this key is paying out twice as much as this key. Well, if I'm a pigeon and I equally distribute my behavior toward the same 50%, 50%, even though the key over here is paying out maybe 70% of the reinforcer, what that tells me is this pigeon has no clue. Okay, it doesn't realize that one of these sides is a better payoff and he should spend more time there. So let's say this is you know, paying out 70% and I'm doing 50-50. Again, there's a pigeon that has no clue. Now let's say this pigeon actually favors the better side, the one that's paying out 70%. The pigeon directs 60% of its pecks, its behavior toward that, and the remaining 40 go to the other side. Now what do we know? Now we know here's a pigeon that recognizes this side is better, so I'm going to give it more of my behavior. However, he doesn't quite get all the way up to a perfect match. You know, matching is like what you should do. He should give it 70% of his behavior. He only gives it 60. Now that's better than 50%. He recognizes this is a better option. I'm going to give it more of my time, more of my behavior. But I don't quite get all the way up to matching. That's undermatching. So if you're looking at the better side and you see what the animal does, and he favors it, but he doesn't get all the way up there, we call it undermatching. It's like he's undershooting his best, what he should be doing. He should give it 70%. He's giving it something less. Now, when we're doing undermatching, it's going to be something less than what the better side is paying out, but not all the way down to 50%, because at that point, we don't know what, you're just clueless pigeon if it's 50-50. So something more than 50, but under 70%, it's going to be undermatching. Okay. Now let's say that same pigeon, this is paying out 70%, this is paying out 50%. He directs more of his behavior. He's like, oh, this is better, I get more food. But he overshoots it. He gives it like 80% of his behavior, even though it's only paying out 70% of the reinforcer. Well, that's what we call overmatching. It's like you kind of overdid it, buddy. Yes, you should give it more of your time and behavior, but not that much. I mean, perfect would be matching, would be 70% of behavior for 70% of reinforcer. But you're giving it 80% of your behavior. You just sort of overdid it. Okay, that would be overmatching. Now, bias is when you favor one of the choices, regardless of whether that's paying out better or paying out worse. So to see bias, you're going to have to be given two situations. I have a green key and a red key. My two schedules of reinforcement on the pigeon. Let's say red's paying out more now. It's paying out 70%, and I give it more than it should get. I basically overmatch in this situation. I give it 80%. Okay. Now we switch things up. Red's only paying out 30% now. It's now the worst choice. But if there's something about the red reinforcer you like, you might still give it too much. Now it's paying out 30%, but it gets 40% of my behavior. Now, first of all, what would we call this specific little situation where this is paying out 40%, but it's, paying out 30%. Red is paying 30%, but gets 40% of my behavior. Well, what's happening on the other side? This is paying out 30, getting 40. That means green is paying out 70, the remainder of the reinforcer. It's paying out 30 over here, so that means 70 here. Now, how much behavior is left over? 60% of my behavior is left over for green. So when I'm favoring red and it's low payout, this is actually undermatching this little piece, because the one that's paying out 70% is only getting 60% of my behavior. So when you see bias, what you're likely to see is in one situation, the thing you're biased toward, if it's the richer schedule, you're going to see overmatching. But if it's the poorer schedule, like it doesn't pay out the same rate, a lower rate, it's still going to get more, and actually that's undermatching. So often in bias, we see a situation of overmatching and a situation of undermatching. But all you really have to remember is if there's a side that the animal gives too much to, it gives more behavior than it should, whether it's a richer schedule or the poorer schedule, we see bias. Now, what would create bias? Well, and in a pigeon with, two keys to peck and get food here and I get food here. What if I gave him a favorite food on this side? And like some kind of seed that he loves and that's his favorite seed. And over here is just kind of like, cruddy cornmeal or something, I don't know, whatever pigeons will eat but aren't really excited about. Okay. If it was a rat, what if a rat got, Purina rat chow on this one, but got Cocoa Puffs on this one? Rats love Cocoa Puffs. You give those little chocolate cereal balls, they're like, cuckoo for Cocoa Puffs. So they might still work for both kinds of food, but they really like the Cocoa Puffs. And so they might be biased. Now, you read the chapter, right? So remember that experiment they did with humans where they had people sitting on, you're having a conversation. The participant in the experiment is in the middle, and there's two people on either end of a table, and they're in on the experiment, but this person doesn't know. And they're directed to pay out reinforcement in conversation by saying, positive comments. So in conversation, if you're reinforcement, people go, hey, that's a really good point. Ooh, I see where, oh, yeah, that's really good. They compliment you on what you're saying. And they could switch up, like maybe this guy's paying out more of these conversational compliments, reinforcement. Well, all they did is they timed how much the person in the middle looked toward that person, and looked toward that person. And they found matching. So if this guy's giving 80% of the reinforcement in the conversation, I'm going to spend 80% looking at that guy. And this guy, 20%, you're like, yeah, whatever. 20% to this guy. So we'll match. Now, let's do bias. What if, this person over here is only paying out 20%. This person is like, I don't know, really good looking, and I think you're really cute, and so I'm biased toward that person. So even though they're only giving 20% of the verbal reinforcement during the conversation, I might be like, hi, looking over there 40% of the time or something like that. That would be bias. And now they switch it up, unbeknownst to me. Now this person's going to pay out like 80% of the reinforcement, and I'm going to look over there 95% of the time. I'm going to be directed this way. So that would be an example of bias. Okay. I think that does it. Read the section when you get to the part where it says matching and amelioration on page 402. You can stop there. We're not going to do that section. So go ahead, read that, and we'll have a quiz. You can go do your quiz.